Hello, viewers. In today's session, we are going to discuss an important and conceptual problem from inequalities in definite integration, right? And here we have this problem in which we are given an integral I that is from -1 to 1. The integrand is cosine x divided by square root of 1 plus x square and dx. And if we are given that the lower and upper bound of this integral I are given by P and Q, then we have to find the value of P and Q, right? So here we are given that this integral I is greater than or equal to P and less than or equal to Q. And our objective is to find out the value of P and Q. P is known as the lower bound of this integral I and Q is the upper bound, right? So to solve these kind of problems related to integral inequalities, we are going to use an important result from uh, definite integrals, right? So let us first briefly discuss the result and then we'll see how we can apply the result to this problem to get the value of P and Q. So viewers, let us consider three functions, say g of x, then we can take f of x and h of x, right? So here we are taking three functions, g of x, f of x, and h of x. And these three functions are integrable in some interval, say a comma b, right? So for all values of x belonging to this interval, these three functions are integrable, and the relationship between these three functions is that f of x, it lies between g of x and h of x, right? So we have this inequality, that is f of x is greater than or equal to g of x but less than or equal to h of x, right? So let us see geometrically this condition on this coordinate plane, and then we'll see an important integral inequality connecting the definite integral of these three functions. So now let us have a rough diagram of the curves representing these three functions. So let us take the first function, that is g of x, like this, and then we can take f of x. Suppose f of x, it looks like this, and then we have the function say h of x, right? And suppose take h of x like this, right? So now here we have this point A, and here we have this point B, right? So now this curve represents y is equal to g of x, and this black curve, it represents y is equal to f of x, and here we have h of x, right? Okay, and here we are taking the 2 points, that is the abscissas are A and B. So now let us take these points as P, Q, and R, right? And here we can take these 3 points as say A, and then we can take B and C, right? So now from the definition of definite integral, we know that this integral, that is from a to b f of x dx, this integral represents the area bounded by the line x is equal to a, y is equal to f of x, and x is equal to b, right? So we'll use this concept here, Now see, this curve denotes that is the g of x. Here we have f of x, and then we have h of x, right? And here we have a and b. So let us call these 2 points as, say, L and M, right? So from the figure, we have three areas, right? So let us take the areas as the first one is P, L, M, and A, right? P, L, M, A. Then we have the area that is Q, L. We can take Q, L, and then we have M, and then we have B, right? And the third area is RL. Then we have RL, and then we have M and C, right? So now we can easily see that this area, that is PLMA, this area is given by the integral from A to B, and we have the function g of x. So we have g of x dx, right? And this area, that is QLMB, right? So this area is greater than the area PLMA. So here we have this area. So this area is given by the integral a to b, and then we have that is f of x dx, right? So now we have this area, that is RLMC, which is this area, right? So this area is given by A to B, and we have the function that is h of x dx, right? So when we have three functions which satisfy this inequality, then the area bounded by them from A to B is given by these three integrals, right? And from the figure, we can easily conclude that the area PLMA is less than or equal to, the equality occurs when all the three functions coincide, right? And here we have area that is QLMB, and then we have the area that is RLMC, right? So this area is the least area, and this area is the maximum area, right? And this area lies between these two areas, right? So now we can replace these three areas by the respective integrals. So we have a to b, and then we have g of x dx, and here we have a to b and f of x dx, and then we have a to b h of x, and here we have d of x, right? So this is the inequality which plays an important role in solving these kind of problems, right? So now let us come to our problem. So here we are given this integral, right? So let us first take this function cosine x, and here the limits of integration goes from -1 to 1, and from trigonometry we know that the cosine function it lies between -1 and 1, right? So this is the famous inequality in trigonometry, which suggests that the cosine function has maximum value 1 and the minimum value is -1. So now let us take this function, that is square root of 1 plus x square, right? Now see, the limit of integration varies from -1 to 1, so our x belongs to -1 and 1. and we can easily see that the expression that is 1 plus x square is always greater than 0 for all values of x belonging to the interval minus 1 to 1, right? Because x square is always going to be greater than 0 or equal to 0, so that 1 plus x square is always greater than 0, right? So now if we take the square root, or in other words we can also say that the square root of 1 plus x square is also going to be greater than 0 for all values of x, right? So now we see that the quantity that is square root of 1 plus x square is never going to be 0 for all values of x belonging to this interval, right? So this quantity is always going to be greater than 0. So what we will do, we'll divide this inequality throughout by square root of 1 plus x square, so that we can get this function which is our integrand, right? So now we have minus 1 over square root of 1 plus x square, and then we have cos x. Here we have square root of 1 plus x square, and here we have 1 over square root of 1 plus x square, right? So now we have got these three functions. So this function may be taken as g of x, this may be taken as f of x, and here we can take it as h of x, right? So from the discussion we have seen that when we have three functions g of x, f of x, h of x in the interval a comma b, then their integral, that is the definite integral from a to b g of x dx, is less than or equal to the integral a to b f of x dx, and then we have a to b and h of x dx, right? So now what we will do, we'll integrate throughout from minus 1 to 1. So we'll get minus 1 to 1, and here we have minus 1 square root of 1 plus x square. Here we have dx, then we have minus 1 to 1 cos x, and here we have square root of 1 plus x square dx, and then we have minus 1 to 1, and here we have 1 over square root of 1 plus x square dx. So now this is our integral I, and let us integrate this function from minus 1 to 1, right? So here to integrate this function, we can make use of the important form of integration, that is integral dx over square root of a square plus x square is equal to the natural log of x plus square root of a square plus x square, right? So here we have integral 1 over square root of 1 plus x square dx, right? So this integral is similar to this one. So here we have 1, so this can be written as 1 square, so the value of a is 1. So we have log of x plus square root of 1 square, that is 1 plus x square, right? And this is the indefinite integral. So to get the definite integral, we have to take the limits. So if we take the limits, that is from minus 1 to 1, we can substitute the limits and we'll take the difference. So now taking x is equal to 1, here we have log of 1 plus 1 square, that is square root of 2, and then we have log of minus 1, here we have minus 1, then here we have minus 1 square, that is 1, so 1 plus 1 is square root of 2, right? So now we can write log of this is square root of 2 plus 1, and here we have log of square root of 2 minus 1. And utilizing the properties of log, we can now write log of square root of 2 plus 1 over square root of 2 minus 1. So now if we rationalize, then we'll get square root of 2 plus 1, square root of 2 minus 1. Then here we have square root of 2 plus 1 over square root of 2 plus 1. So multiplying the numerator and denominator by square root of 2 plus 1. So now we have log of, here we have square root of 2 plus 1 square, and then here we have a minus b, a plus b form, that is a square minus b square. So this is square root 2 square minus 1 square, that is 2 minus 1, that is 1. So here we have simply 1, right? So the value of this integral is equal to a log of square root of 2 plus 1 whole square, right? So now taking the square of square root of 2 plus 1, we have 2 plus 1 plus 2 times square root of 2, that is log of 3 plus 2 times square root of 2, right? So here we have the negative sign, which we can write outside the integral. So now this integral takes this inequality takes the form, here we have negative sign, and the value of this integral is the log of 3 plus 2 times square root of 2, and then less than or equal to sign. Here we have I, which is our integral, and here we have the positive sign, so we have positive, and the value of this integral is log of 3 plus 2 times the square root of 2, right? So viewers, if we compare this inequality with this one, that is P less than or equal to I less than or equal to Q, then we can easily see that the lower bound or the minimum value of this integral I is given by P, which is negative log 3 plus 2 times the square root of 2. And the upper bound of this integral, which is the maximum value of this integral I, is given by q, which is given by positive log 3 plus 2 times square root of 2, right?